Hello everyone, especially to our lecturer. My name is Salah Sinalai. The student ID is 57214225 So today I will be presenting my week 6 database setup presentation. The project title is Atimeo classification using Comnex. This project focuses on how we prepare and organize ECG data so that a deep learning model can classify heart rhythm disorder accurately. Right? Which is the database or dataset overview. The dataset I use is the MIT BIH Athemia dataset, which is provided by Visionet. It contains ECG recordings sampled at 360 Hz from multiple patients. Each recording is annotated with Athemia type such as normal, premature ventricular contraction, and atrial fibrillation. This dataset is widely recognized in research, making it reliable and suitable for training and evaluating classification model. So let's go through to the next slide, which is the segmentation strategy. As you can see in this slide, ECG signals are continuous, so we need to break them into meaningful pieces. I use R-peak detection to identify the highest point in each heartbeat cycle. By segmenting the signal around this R-peak, we can isolate the individual heartbeats. Each segment is then labeled according to its arrhythmia type. This step ensures the model learns from precise cardiac cycles rather than low, noisy signal. Okay, let's go through to the next slide, which is the preprocessing pipeline. As you can see in this slide, after segmentation, preprocessing is applied to clean and standardize the data. First, a bandpass filter between 0.5 and 40 Hz remove baseline drift and high frequency noise. Next, normalization ensure the consistent amplitude across the signals. Then I convert the ECG segments into spectrogram using the short time Fourier transform. Finally, these spectrograms are resized to 234 by 234 pixels to match the complex model input requirements. This pipeline prepares the data for the deep learning. Okay, let's go through to the next slide, which is the data split strategy. As you can see in this slide, to train and evaluate the model properly, the data set is divided into the three parts, which is 70% for training, 50% for validation, and 50% for testing. The training set teaches the model pattern in the data. The validation set helps tune the hyperparameters and prevent the overfitting. The testing set provides an unbiased evaluation of the final model performance. This split ensures fair and reliable results. Let's go to the next slide, which is the conclusion. In summary, the dataset or database setup involves four key steps, which is the selecting the MIT BIH dataset, submitting the ECG signal using RPIC detection, reprocessing them into the spectrogram, and splitting the data into training, validation, and testing the set. This step form the foundation for training Compnex to classify arrhythmias accurately. With the setup, we can build a review system that can support automated healthcare monitoring. That's all for my presentation today about the week 6 database setup presentation. And please find the link to my YouTube presentation about this slide presentation today. Thank you.